All right, guys. So this week you guys are going to be doing a trig graphing project, and more than likely you will be using Desmos. So all this do now is going to be some quick tips on how to use Desmos. I would highly encourage you opening up Desmos in your browser or maybe in a second window and be going through this while I'm going through this, and that is what your do now is going to consist of today. So first off, let's look at our graph, and you are going to go to this little settings bar up top. Since we're graphing trig, we're going to change our x-axis to count in radians. So I'm just going to say, let's do -2 pi, and then let's go all the way to, let's do 6 pi. And then the step is like, what's it going to count by? So right now, the step is always going to be counting by ones automatically. But because in trig, we normally count by pi over 2, I'm just going to type in pi divided by 2. And that should relabel my axis. My y-axis is fine. We count by ones. That's great. So let's just keep it there. Let's also get a check off. We can yeah, honestly, this is fine. We're in radians, which is what we want. You can add labels if you want to, but you do not have to. Now that I have these values and my graph set up how I want it to, I can start graphing. So if I can say right here, let's do sine of x. Some cool features of Desmos is you can add a slider. So for example, if I put a value a, I can add a slider a, and I can manipulate my sine graph for any value of a without having to physically type it in. And you can add in multiple sliders. It doesn't just have to be one. So if I want to add in a phase shift, I can say x plus b, and I can add that slider b and shift my sine graph. Last really cool thing that you can do here with your values, and we could even add, right, like you can add so many different things. You can do a c and add a slider and change the frequency, and then you can do another slider value, and that will change that baseline. Our last thing that we can do here that's pretty cool is we can add a domain restriction. We add a domain restriction by pressing that shift bracket to get the squiggly bracket, and then you can set your boundaries. So let's say that I want to only show from 0 to 2 pi. Now my graph is only going from 0 to 2 pi. And again, I can move this guy around. If we added a second graph, I can also do a similar. Let's say that I want this to go, it looks really crazy right now, but let's say I want this to go from 2 pi. And how I'm getting the pi value is I'm just typing pi, and it automatically converts it into the pi sign. So let's go from 2 pi to 3 pi. Cool here. And then let's make sure we're adding those sliders. Cosine of x. And what I realized here is that if I use the same variables on cosine, it's just going to change with my sine graph. So you can choose a new variable coefficient. So I might choose g right here, and I can change that. And the reason this is useful is you can start connecting these graphs and start making this kind of like a piecewise function. So I could say h cosine of hx. There we go. And I can add a slider here, and I can start flipping this around in order to create some graphs that joint together. Last thing we're going to check out is how we can do this on a graphing calculator. So on your calculator, what's important, and I know we've gone over this a little bit in previous videos, but your window does need to be set to where it best matches your graph. So if I go here to window, let's change this in order to fit a trig function. Let's say my minimum is 2 pi on my x value, and remember we're always doing this in terms of pi. Let's say my max is 6 pi, so 4 full periods in total for a normal graph without any sort of transformations. And then let's change our x scale to count by pi over 2, which is what my unit circle normally counts by. Y min, I'm going to change that to -5 to 5, and it doesn't matter really here. That's just going to zoom it in a little bit more, so it's not going to look so zoomed out with my amplitude of 1 is not going to look so tiny on my graph. Here's what he looks like. And if I go to y equals, I can insert any equation. Let's do cosine of x. And let's add an amplitude. So second delete, so it inserts. Let's do an amplitude of 3. And there's my cosine graph. And you should notice that all those key points here are matching up, and they're counting on a pi over 2. If you go to your table of values, all these y values are going to look like nasty decimals pretty much. And the reason why is because that we're still not counting appropriately. So I can go to second window to table set, and let's change our table to count by pi over 2. Now, when I go to my table, it should look a whole lot nicer because all these values are cycling through in counts of every single pi over 2. The last really cool thing that your calculator can do, let's go back to the graph, is it can find specific values. So if I say second trace, so going into that Calc menu, I can say I want to know a value, and I can input any x value. So if I want to know what's the value of the graph at pi over 4, I can press enter, and it lets me know that the output there is 2.12. I can also say, all right, what's the output when my input is 5 pi. When my input is 5 pi, my output is -3.